So my name is Chris. I'm a solutions architect with Hewlett-Packard Networking, and I do cover Washington and Oregon. So mostly for mid-market and commercial. I don't do any SLED accounts, so no state and local education, or no state and local government, K through 12 or higher ed. But anyway, any questions, swing back by the HP booth here and talk to Marin or I. We are auctioning off a HP Slate7 Extreme, so drop your business cards back there. It's a 7-inch Android tablet if you're interested. So we'll jump right into SDN. So is there anybody that's currently actively researching SDN, have any deployments in the lab, done any reading on it, or is it just a buzzword that you've heard? Anybody actively using it? No? Okay, so we've heard, you've kind of heard the theme of SDN throughout the day in several of the presentations. A lot of the technologies that the other partners here have talked about integrate with SDN-enabled networks and technologies. So just within the industry in general, we're seeing a shift in IT, right? We're seeing converged infrastructure being implemented. That's where you've got standard data and storage protocols in flight over the same wire at the same time. Converged cloud, so we're seeing private and hybrid clouds being built in more and more of our customer environments. Software-defined data centers. This, which one is the actual pointer? That is. So HP, you can talk to us sometime later about the actual HP data center transformation, but in a nutshell, we consolidated north of 80 data centers that we had installed across the globe into 3 pairs of data centers across the southern tier of the United States. So all of our 3 DCs, again, they're paired, they're all active. Absolutely every application in all 6 of the physical buildings is live, and we have full recovery and failover from any application between all the data centers. So we actually have rolled this out and actually employ this in our network today. So anyway, come and talk to us about it if you're interested. But suffice it to say, once you start seeing these technologies, these software-defined data centers built, you can spin up something like an Exchange organization that has X number of front-end servers, X number of back-end servers, DB servers, all of that stuff literally in a matter of minutes, from the time that you actually send in the app request till the time that the compute and storage environments are provisioned and the network environment is built. So one thing that those technologies are bringing to light is that the way we build networks today, it's really too complex to allow those provisioning mechanisms to work effectively, right? So today, in most networks, we really haven't changed the way we manage networks for 15 years? So an IT individual, when a new provisioning request comes in for whatever service, whatever application, whatever server to be added to the network, an IT individual usually has to sit down and program, configure at least, one switch. But just suffice it to say that every single network element today, router, switch, access point, it is all configured manually by an IT individual. There are some systems out there from, like us with our IMC, our Intelligent Management Center, that'll allow you to configure multiple devices via jobs, but it's still not a real-time scenario, right? You build this configuration job, you distribute it to 1 or more devices, and it takes place either, right now, meaning however long it takes that management system to SSH to the boxes and make those changes, or it can happen in the future if you schedule it, but it's not a real-time dynamic provisioning. So consequently, the network really has become the bottleneck to cloud environments. When you think about, if you guys are looking at deploying private cloud environments today, you can spin up compute and storage resources in a matter of minutes for whatever services you're trying to roll out. And then when it comes to the network, though, again, you're back to creating a work order that's submitted to your IT department. An individual goes out and actually configures the devices that are required, but it's a manual process. There are some automation pieces in place today that'll help, like hypervisors and network resources. It'll allow hypervisors to provision network resources kind of in an automated fashion, but again, it's not necessarily a dynamic real-time provision. So what SDN promises, or what it brings, is if we look, it's going to give us a way to dynamically configure multiple network elements in real time and with consistent policies across the entire network. So if you look at the way that legacy switches and routers were built, so we'll pretend this is a big HP Comware, like a 12500 data center switch, right? We own the chassis, we own the line cards. So the hardware is proprietary. We designed it, we built it. The operating system is proprietary, we wrote it. And all the features that operating system provides, obviously they're proprietary as well, right? We wrote the code, we own the IP for it. So when it comes to purchasing these devices, and this is true for any manufacturer, really the manufacturer's profit margins are what is driving the features as well as the rate of development for these products. So when you look at SDN, what it does is it takes the control plane. So you think about the control plane as a component of a networking device that controls things like routing protocols, how QoS is provisioned, all that good stuff. The forwarding plane is actually what takes the information the control plane has entered in it, and it'll then use that information to modify packets and forward them on through the network. So in SDN, at a minimum, you decentralize the control plane from these switches, and you put that control plane into a virtual machine or an appliance. It's called an SDN controller in most cases today. And that SDN controller is logically centrally located in the network. The reason I say logically is because they can be clustered, they can be installed in a hierarchical fashion, so they're not always in the same data center, but it's a single SDN controller instance. So on top of that, we provide open interfaces. They're generally Java-based and REST-based APIs that we can then write applications to, and those applications can actually dynamically provision the network. So one consequence that I think we'll see, or one result that I think we'll see from that, is that obviously these applications, remember I said these are open interfaces, right? We publish an SDK. Anybody that has developers in-house can write applications to then affect the network. So these applications that are going to be written, the rate of development and the pricing is going to be defined by the market versus HP, Cisco, Juniper, margins. So it really kind of it puts the buying power for a lot of this stuff into the customer's hands. So now I talked about we decentralize that control plane, right? We set that in an SDN controller. Well, the switches, the devices that actually forward packets, they still need to have a way to be configured, right? So we need a protocol that those switches can use to register with that controller to receive their intelligence and be kind of configured in a dynamic fashion. So OpenFlow is that protocol it's a protocol that we have deployed. So OpenFlow is actually an open standard. It's maintained by the Open Networking Foundation. So you can go to opennetworking.org and read all about this protocol. We've rolled out version 1.3.1 in over 50 switches. And this protocol was actually developed back in 2007 when Stanford came to us. They had a requirement for being able to centrally configure certain areas of their network so they could view, monitor, and affect student traffic. Anyway, they wanted to do that in a centralized fashion versus going out and configuring each device autonomously. And they also wanted to be able to take quick action if something was happening that shouldn't be. So anyway, they came to us, and so it was a joint Stanford HP working or partnership, and it was the original project was called Ethane, but the result was the OpenFlow Protocol. Since then, it's been turned over to the ONF. They maintain it. I mean, it's almost works just like a standards body. There's a bunch of different working groups that test interoperability between manufacturers, define features. OpenFlow can actually, there's a bunch of matching criteria, and based on how we match, whether it's by like source port, source MAC address, source IP address, we can then do, if we match on a certain criteria, we can then take an action on it. That action could be encapsulate and tunnel that traffic or that packet across my network and egress it on port 36 on this switch. It's really, you can do anything you want with it. So anyway, this protocol is maintained by the ONF. So HP isn't driving features. It's all the working groups and all the chairs of those working groups and their individuals that are driving features and building it into this protocol. And we'll continue to use this ongoing. So any manufacturer that's actually using OpenFlow, lights will start going on at this point. If an Ethernet switch supports OpenFlow, it should be able to register with and work with any SDN controller. So you can buy an HP SDN controller and throw our switches in, throw Juniper in if they support OpenFlow. Cisco has not committed to supporting OpenFlow, so that you won't be able to do that with theirs today. IBM has. NEC has some products that do. So there are a bunch of people that are supporting OpenFlow. So when we look at it actually, and this will kind of start putting the whole SDN puzzle together for you now. So there are three functional areas of SDN. So there's an infrastructure layer. So an infrastructure layer, just think of that as, at that layer, that's where we modify and forward packets. There's a control layer. So that control layer, that's where we take the control plane out of the routers and switches. We put that into a central location. With that control layer implemented, I now have a way to affect that infrastructure layer, to configure it on any number of devices in the network, right? So at this point, with these two layers actually built, we'll talk about this on the next slide. Then we have an application layer. The application layer is what allows your enterprise applications, things like Microsoft Link, to then dynamically talk back to the control layer, configure your network. So when we look at the components, so obviously the infrastructure layer, those are networking devices, routers and switches. If we look at the control layer, that's an SDN controller. And what I was going to comment on before, at this point, I've technically built an SDN. I've decoupled the control plane. It's centralized. So technically, I can say I built a software-defined network. But really, I've got switches and SDN controllers sitting there that are doing nothing for me. I mean, I can SSH to the controller. I can enter static flows. I can use IMC to enter static flows, but it really doesn't buy you anything from a networking standpoint. So really, where all the payback, the gain for an SDN is when you start installing or using your existing enterprise apps to then communicate through that SDN controller and dynamically configure your network to deliver the best end user experience for that application. So I'm not going to go deep into flow concepts at this point, but just taking a second. The whole stoplight theory, if you think about autonomous devices, like a switch that's not in an OpenFlow network, if a packet ingresses it, there's a lookup internally on that switch. That switch itself makes a decision on where to send that packet based on its layer 2 forwarding tables and its layer 3 routing tables. SDN takes a look at your network as a whole versus just that single autonomous device. And an SDN controller, if a packet matches a certain criteria, can actually affect how that packet traverses your entire network. We can set QoS parameters. We can define which uplinks to take. It's crazy what you can actually do with it. So SDN actually has more of an end-to-end view of the network versus kind of an autonomous look that like single switches and routers do today. So you look at applications themselves. Typically, today when we provision a network, we take a look at the applications we have on that network. As a general, let's say looking at the client server side here, this might be things like Microsoft Exchange, file and print shares, some web traffic, right? And we start piling on more applications. We take a look at bringing in mobility, bring your own device. That puts more stress on the network. Well, at this point, the network is under provision to provide the type of end user experience we need for our in-house apps, as well as mobile devices. So at that point, we'll usually add more capacity or re-provision the network. Now, this can be QoS profiles that we modify. It could be more switches, faster switches, more uplinks. There's all kinds of different provisioning mechanisms. So, but this is done manually. It's done by a user, and you're using some sort of either network monitoring system or show commands at the CLI to actually take a look at what your traffic is doing to determine when you actually have to re-provision your network. So I'm going to just take a look at a real-time scenario on this network provisioning. So right here, we have, and this will actually take a look at a very specific SDN app, and then you'll kind of see how this all works together. So we have a user in a desktop sharing session. They're sharing a PowerPoint presentation and a video. And we can see that at the other end of this link, the person that has joined that desktop sharing session, the PowerPoint slides are not in sync, the video is not in sync. And so this is the type of experience that you'll see across a saturated network or an under-provisioned network. The application obviously is Microsoft Link. So we developed an SDN application, Network Optimizer. And what it does is that when this user, James, initiates that initial call over to Linda, so he starts the desktop sharing session, the Link server actually sets that communication up, right? James signals to the Link server, I'm going to talk to Linda. The Link server is actually what joins or makes the call to join those two endpoints. So with SDN in place, there is an SDN API within Link that can actually communicate over to our Network Optimizer application, which then tells the SDN controller to provision flows. We call those flows versus forwarding entries. Those flows are sent to the TCAMs, which, I mean, they're sent, I'll try not to get too deep into it, but they're sent to each of these switches, right? And they're hardware based. Those flows are actually inserted into the hardware of the switch. They're not inserted into just the running memory of the switch. So it's not a software based flow. And one thing that's important to remember, OpenFlow has direct access to the forwarding planes of these switches. So it's not like this thing is telnetting or SSHing to these devices and issuing commands. That flow is sent instantaneously. I mean, so it's like after that initial call, after that first packet is set up to Link to start this communication, those flows are immediately built and sent. What those flows do is they say, okay, any traffic from James' PC going to Linda just for the Link application, automatically set that into hardware queue 7 on my port. So it prioritizes that traffic higher than anything else between those going across the link between the two switches. And the end result is that the PowerPoint slides are in sync, the video's in sync. So, I mean, that's a perfect example of what SDN can do for you. And the important thing to remember is that the IT staff didn't have to do anything for this. I didn't have to pre-provision QoS policies. I literally didn't touch a switch. The application took care of provisioning the network for me. And so now when either James or Linda leaves that session, they signal to the Link server that, hey, the session's over. The Link server tears that session down, communicates to our SDN controller, and he takes the flows out. So making sure I'm okay for time. So as you can see, what it does is it gets rid of this whole manually provisioning steps, right? So your network admin doesn't have to do anything. SDN will dynamically provision the network to meet your app requirements. Some other features from that, obviously, there's a decent interface, so you can look at call detail records for any call that traverses through the app as well. I can see things like latency and jitter, QoS markings. I can see SDN controller status, all kinds of stuff through this. So, and this just kind of shows the breadth of our SDN offering. So we do today, within our SDN architecture, we have 50 switches, actually a little north of 50 switches that are SDN enabled, meaning they support OpenFlow. We have our own controller, which is in its second release, and a handful of apps. So I've got 2 minutes, so I'm gonna fly through a few slides here. So VMware, a few years ago, they purchased a company called Nicira. Nicira was building what at that time was called an OpenFlow controller, that now would be referred to as an SDN controller. So then they took that product in-house, went through some more development cycles, and released it as NSX. And VMware NSX allows them to implement SDN type functionality within the hypervisor. So that's from VM to VM. The problem there is that overlay cannot see or function with any of the individual components on the actual physical underlying network. So we've built an actual federation between VMware NSX and our controller that allow those two environments. It unifies the visibility into those two environments between the VMware environment and the physical SDN network, and it allows SDN apps to span both environments. If you have open source-based hypervisors, we have hooks into HPN Cloud OS, KVM. This application, the VCN app, will allow you to build your own public and private, or private and hybrid cloud environments. And it gives you the actual integration with the SDN networking components that you need to build or roll out services. You know, I can roll out services without SDN. However, with the SDN optimization in here, I can actually dynamically provision the underlying network resources as well as just compute and storage. Okay, Network Protector. This is a way to take our rep. So is anybody familiar with tipping point IPS? So there are a bunch of, there's a couple different digital vaccine databases. RepDV is a catalog of internet sites. Each site has a reputation associated with it, anywhere from bad to good, right? I can actually define a reputation level that I see as acceptable in my organization, and then enable that on my SDN controller. Now, whenever anybody tries to talk out to the internet, that reputation is checked, or the destination site is balanced against RepDV, and it's either allowed to go or not. So my friends at Kaspersky, when they were talking about the phishing emails that you get with links in those, and somebody, you know, sometimes somebody doesn't actually look at the link to see what the URL is, and if they click on one that's bad, most likely this is going to stop that before it ever even gets past the access switch. So we have an ecosystem, we have an app portal. So kind of like iTunes from an SDN standpoint, you can go out to that app portal, download and install apps on your SDN controllers. And this is the last slide I'll make you guys sit through. So right now, you can actually deploy SDN-enabled switches. I have customers that have it deployed in a lab. I have POCs deployed, but they're generally for a very specific use case. We have a few customers that have something like the Link application deployed. Again, SDN is being used for very specific cases today instead of just installed in general across the enterprise network. You're going to see more apps come out over the next couple of years. It's probably going to be towards the end of 2016 before you guys really start seeing your peer companies deploy this, you know, across the enterprise in general. So, oh, we have training and implementation services as well. So that's it.